Hey students, welcome back to another video. Today we'll be doing another paper of course code 0625. It's paper 4 from October-November 2024. So the first question of the paper is saying that there is a rocket that has an initial mass of 7.4 into 10 raised to power 6 kg, and we have to get the initial weight of this rocket. Weight is equals to m times gravitational acceleration. Mass is 7.4 into 10 raised to power 6, and gravitational acceleration is always 9.8. So the answer is 7.3 into 10 raised to power 7 Newton. Next part of the question is asking to define weight, and weight is the gravitational force acting upon a certain amount of mass. B part is saying figure 1.1 shows the part of speed time graph for the rocket as it leaves the ground and travels into the space. On y-axis we have speed, on x-axis we have time, and you can see that from 0 to O it's curved. From 0 to O it is like a curved shape, and from A to B it's a straight shape. We have to describe the motion of the rocket from O to A and from A to B. And to understand this graph concept, let us just consider this velocity time graph. Over this, the slope or the gradient of the curve represents acceleration, and the area under the curve shows us the distance traveled by any certain body. As you can see that this curve is straight, there is no increase or decrease in the velocity, so you can say velocity is constant, and the slope of straight line is always 0, so we can say that the acceleration is 0. The second shape is like this, and the velocity is increasing, but the increase is uniform. Same increase in same amount of time, but for the acceleration, it is positive, but this time the acceleration is constant. The same amount of acceleration over the entire period of time. For the third graph, the velocity is decreasing uniformly, and again the acceleration is negative yet constant. Fourth graph is curved, and this time the increase in velocity is no longer uniform, it's non-uniform, and acceleration is no longer constant, it's increasing acceleration. So if we see our shape from 0 to A, it's very similar to the fourth shape of our graph. That means the acceleration is increasing and the velocity is also increasing, but non-uniformly. So I'm writing it over here. Velocity is increasing, but the increase is non-uniform. Plus the acceleration of the body is increasing. Over from A to B, there is a straight line. That means velocity is increasing in a uniform manner, plus acceleration is constant. So I wrote it from O to A, acceleration is increasing, and from A to B, acceleration is constant. Second part says draw a tangent to the graph at time t equals to 400 and use this to calculate the acceleration of the rocket at that time. Show your working. So we will draw a tangent at time t equals to 400. So at this point, I am going to draw a tangent first. While drawing a tangent, make sure that the distance of the line from the curve on both sides of the point should be same. And I have drawn the tangent. As I have told you, to get acceleration, we need to get the gradient. So I am marking any 2 points on the line. You're free to choose any 2 points and mark the coordinates of the point. Name one coordinates x1, y1 and the other coordinates x2, y2. Now put the values in the formula of gradient. 0 minus 8000 over 200 minus 600. It would be negative 8000 over negative 400. Negative got cancelled out, and the answer is 20 meter per second squared. So this is your acceleration, and make sure that you show the working on this side. I've just shown it on the graph, and you'll secure your 2 marks after it. Now the next part is saying that the rocket are used to launch satellite into the space. When satellite is released, the rocket returns to the earth. Explain in terms of forces why the rocket reaches terminal velocity as it travels through the atmosphere back to the earth. Firstly, what is terminal velocity? Terminal velocity is a constant velocity. While returning to Earth, it maintains a constant velocity. Why? For example, this is Earth and this is a rocket which is returning back. So the rocket is being attracted by the gravitational attraction of the Earth, and there is also an opposite force of air resistance, or we can say drag force. As soon as the gravitational force is equals to drag force, the rocket will achieve a terminal speed or a constant speed. So to get a terminal speed, the drag force or air resistance should balance the gravitational pull of Earth, then a terminal velocity is attained. Question number 2 is saying figure 2.1 shows a golfer about to hit a golf ball. The initial momentum of the ball is 0. So here is a ball and the initial momentum of the ball is 0. What does it mean? That initially that this ball is at rest. A part is saying to define momentum. Momentum is the product of mass and velocity of object at any certain point. And the next part is saying that the golf club is in contact with the ball for 5 into 10 raised to power negative 4 seconds. The velocity of the ball as it leaves the golf club is 41 meter per second and the mass of the ball is 0.046. We have to get the impulse of the ball. To get the impulse, let me just clear some facts over here that initially this ball is at rest and the momentum of this ball initially is 0. And when the person hits the ball, its velocity becomes 41 meter per second and its mass is 0.046. So the momentum would be, I've already told you, its mass times velocity, and mass is 0.046 times 41. That means final momentum of this ball would be 1.886. And to get impulse, we have two formulas to get impulse. First is forced into time, and the other one is that impulse is equals to change in momentum. That means final momentum minus initial momentum. I can't use the first one because I don't have any force at this time, but I can use the second one. I know the final momentum, which is 1.886, and I know the initial momentum, it is 0. Subtracting both will give us this, and rounding it off to two figures would be 1.9 Newton seconds. Second part is saying that we have to calculate the force applied on the ball by the golf club. So again, I'll use the first formula. To get force, I'll rearrange it. The impulse is 1.9 and the time is already given by the question. I'll put it over here and I'll put all these into my calculator and I will get 3800 Newton. This is the final answer. Okay, question number 3 is saying state two energy resources for which the radiations from the sun is main source of energy. Like the sun is the main source of energy. So we have to name two energy resources. The first one is geothermal energy and the second one is solar panels, or you can say solar cells as well. B part is saying that a wind turbine is used to generate electricity. The useful output from the turbine in 1 second is 6000 joules and the kinetic energy of wind hitting the turbine in 1 second is 11,000 joules. The velocity of the wind hitting is 6.3. We have to show that the mass of air hitting the turbine is 550 kg. Okay, so we have to find the mass of air hitting the turbine and we know the kinetic energy of air hitting the turbine. So I can use the formula of kinetic energy, which is half mv squared, putting the value of kinetic energy over here and the velocity as well, which is 6.3 meter per second. and I'll take square of it as well, and after it I'll rearrange my equation with respect to m. So it would be 11,000 times 2 over 6.3 squared, and when you will put it into your calculator, you'll get 554. Round it off to two significant figures, it would be 550 kg. Second part says calculate the efficiency of the turbines. You may assume that the kinetic energy stored in the wind is transferred to the turbines. So kinetic energy of the wind is basically our input, and the output is already told by the question, it's 6,000, and efficiency is energy output over energy input times 100%. The output energy given by the question is 6,000 and the input energy is 11,000 multiplied by 100. This will give us 54.5. When we round it off, it would be 55%. C part says that tidal energy and wind energy are both renewable energy resources. Suggest one reason why tidal energy is more useful energy resource than wind. Ignore the cost and construction and maintenance things. So basically the wind pattern is very unpredictable, but the pattern of waves is very predictable. And the next thing is that the tidal pattern is more regular than winds. So I wrote that tidal pattern is more regular and it is more predictable. Next question is saying that figure 4.1 shows a pressure cooker on an electrical heating element. The cooker has top fitting lid. This is electric heating element. This is half filled water and upside there is a lid. Part number A says the pressure cooker is half full of water. As the water is heated, some of the water evaporates before the water boils. So describe two differences between the evaporation and the boiling of water in the cooker. So the basic difference between evaporation and boiling is that evaporation take place at any temperature, but boiling take place at only boiling point. Second, that evaporation occurs at surface, but boiling can occur throughout the liquid. Next part is saying as the water is heated, the pressure of the gas inside the cooker increases. Explain the increase in the pressure of the particles. Basically, for example, this is the water. When the temperature rises, the kinetic energy of the molecule will rises and they will start moving faster than before. So kinetic energy is raised. When the kinetic energy is raised, the molecules will hit the walls of the container more often as they were hitting before. So this increases the pressure. I wrote that when temperature is increased, the kinetic energy of particles is increased. They start hitting the walls of the container more often. Thus, the pressure increases. And this will get you 4 marks. Question number 5 is saying on a sunny day, the temperature of black tarmac road and the air above the road increases. Explain why the surface temperature of the tarmac road increases. As it is road and it's solid, so it will absorb the radiations from the sun and the molecules will gain kinetic energy. B part is saying that state the method of thermal energy transfer from the tarmac to the air immediately above the road. Okay, so the air which is immediately above the road is in contact with the road. And this is the more closer picture of it. So the particles of the road are solids and obviously they can't move. So how will they transfer their heat? They will pass on their vibrations towards the air. So this process is known as conduction, in which the particles actually don't move, they only pass on their vibrations. C part is saying state the main method of thermal energy transfer from the air immediately above to the road and the rest of the air. So from air to air, these both are gases and their molecules can move from one place to another. And when there is heat transfer by the actual movement of molecules, this process is known as convection. So I'll write convection over here. D part is saying explain why the surface temperature of tarmac is higher than the surrounding air temperature. We know the question have already told us that the tarmac is made up of black color, and black color is good absorber as well as bad emitter. So it will absorb the radiations from the sun very good. It will get heat ups quickly, and the other thing is that it will not emit the radiation, and it will also prevent the heat loss from the road, and this thing will make it more hotter than the outside environment. I have written it is black, so it is a good absorber of heat and also a bad emitter of heat. That means it also prevent the heat loss. Hope so you like the video. If it's useful, please hit the like button and subscribe my channel.